Welcome to this presentation. We are going to be going through finding the modulus of complex numbers. For purposes of the video and for answering questions of this nature, I'm sure at this stage in your mathematic career that you understand this, but let's go through it anyway. So a complex number is going to be denoted by z, and it's going to take the form of a plus b multiplied by I. The absolute value, or the modulus, of z, the complex number, is going to be equal to the root of a squared plus b squared, and that's basically because of Pythagoras' theorem. So when you're trying to find the modulus of a complex number, all that you're trying to do is to find the distance of the coordinates of that complex number from the origin. And we are going to start off with finding the modulus of 3 plus 4i. And all we're going to do is we're going to use this formula here, and we're going to plug in the numbers. It's really quite simple, as you will see. So the first thing that we're going to do is we're going to do 3 squared plus 4 squared, and then we just work that out. So we're going to simplify that, which will be 9 plus 16. Which is going to give us root 25. That's not a third, because square root of 25 is 5. And that is the modulus of 3 plus 4i, as simple as that. All you need to do is plug in the values, work through the calculus, and you arrive at the answer. Pretty simple start. Moving on to the next one, we have to work out the modulus of 19 plus 19i. And we're going to do this in the same fashion, but it gets a little bit more advanced. So we have 19 squared plus 19 squared. And that just simplifies basically because we have two 19 squareds. So what we can do is simplify that. And what that will give you is 19 squared times 2. If you do and this is all under a square root, and if you do the maths, what will basically happen is the squared and the square root will cancel out, which just give you 19, and then we end up with root 2. Can't simplify that anymore, so we leave that as the answer. So it's a little bit more advanced because sometimes some of the numbers that you generate underneath the root means that you don't do it the way that we done this one. There's a little bit more to it. As long as your mathematical grounding is strong, you shouldn't have any problems with these sorts of questions. I just want to run through the minus I next because this is something that might catch a few people out, even though it's actually really simple, as you will see. Let's go over this last example then, because this might catch some people out, but in reality we're not going to do anything different. We are still going to use this formula. It just might trick a few people because it doesn't look like we can use it. Now let's not forget that if we are going to take the modulus of minus I, we're going to use this. Now the first thing that we need to do is find out the value for a squared, or a. And there is no a, so it's actually 0. It's actually in the form of 0 minus 1i. And because a is equal to 0, we just leave it out. The next thing that we're going to do is we're going to put in b. What is b? Well, b is 1, because remember, we don't write 1x, we just write x. So let's not forget that this does actually have a coefficient, and that is 1. So effectively what we're going to end up with is the square root of -1. And of course, that will just give you 1. And that is the answer. It is really simple, but it's one of those where they might catch you out because they sort of teach you how to answer these in these forms. When you go to use the formula, you think, can't use the formula because it's not in that form. Well, let's just put it in that form. A is equal to 0, so let's just write 0. And then we have the coefficient b is just equal to 1. So let's just plug everything in as it is. It'll just give you 1. And that's as simple as it gets.